Hello, and welcome to another episode of the vBrownBag IT video podcast, where we bring you experts in the wide world of technology to talk about their favorite topics. Kind of like a show and tell for tech geeks who want to learn something new. Tonight, we are continuing our NSX 4.1 series with the illustrious, the amazing, the just as bald as me, Britton Johnson. Hey, Britton, how you doing tonight?
I'm doing well. I'm pulling out the rest of my hair, but you know,
this is what happens in this phase of our career, where we've gotten to the point where like, you're watching all the junior engineers making the same mistakes that we are, and you're just yanking the hairs out as we go.
Your beard game has bested me because you're just on point. So
you know what? It's just laziness.
That's what I keep telling people too. Yeah.
It's not crafted. It's not coiffed. It's not on purpose. It is just sheer laziness. Unlike Kyle Ruddy, who has an epically coiffed beard. All right.
Yes.
Before we get started, let us do a couple of show notes. If you want to get in on the conversation, you can @vBrownBag me. I will be paying attention to the Twitter sphere. If you either @vBrownBag or #vBrownBag, I'll pay attention. If you have any questions for Britton and you are in the live studio audience, I will be answering questions from there as well. I will curate your massive selection of amazingly well thought out questions and pose them to our genius du jour. All right, you have the power.
Okay. Disclaimer slide. I like to leave this up for 15, 20 seconds or so to give people and the lawyers protection against things that I might accidentally say. So
do not attempt this at home. We are trained professionals.
Yeah. But realistically, there is nothing in this presentation that is not already released in public. So we really should be good. I'm not that stupid that I would share things that are, future facing roadmap that no one's allowed to talk about. So this is all stuff that is fully generally available and is, in the product today. So, have fun as which. I'm Britton. Once again, I'm Britton Johnson. I'm a V expert. I'm an NSX SE, or a VCN SE, they call us nowadays. And as Chris mentioned, I am on Twitter for really just mostly work stuff. I'm doing a little bit of personal stuff here and there, but I try not. I'm not one of those controversial Twitter people, like Chris is sometimes. So
controversial. I talk about cats. Cats are controversial now. I know it.
Maybe. Well, yeah, because they're fake. Is it real? Is it AI? Which one is
fake
it?
Cats. Yeah. Fake news.
So today is the NSX software defined networking. That's what SDN stands for. And I pivoted this a little bit, or I'm actually going to talk about Federation more, because after the last week, and I kind of touched on Federation briefly, I kind of realized that the original 2 vBrownBag NSX series that I did, Federation wasn't really a thing then. So so now that it's kind of fully available with Federation in its all of its glory, I think we're going to go a little bit deeper into what that looks like, and especially on the networking side, and show kind of failure scenarios and things like that. So the general plan for today is NSX, and I should have changed the title here because we dropped the T, as I mentioned before. It is just NSX now, and so we're going to talk about software-defined networks and Federation, and what that looks like in a 4.x scenario. So that is where we are today. So quick overview agenda, and for people who are interested in the Federation discussion on this, if you just Google this NSXT Federation 4. Whatever, the product management team member who built this actually put this out on the VMware communities page, so you can download this slide deck directly from the communities page. It's fully available to the public. So if you want, to grab any of these slides, they're freely available for all VMware community people on the communities.vmware.com, I think is the link, but you'll find it in the Googles. Dimitri Dismit on our product management team is the guy who crafted all this stuff together. I'm just sharing his genius and taking credit for it. So, let's see here. So again, we'll go through a little bit of networking review, talk through NSXT 4.0 enhancements for Federation, and we'll go through really what Federation looks like, kind of in a high, mid to low level view. So really kind of beginning stuff. Okay, where we start here. So in the beginnings of building a NSX software-defined networking architecture, you kind of have to start from this bottom-up view. So when we look at this, we're talking about, your ESXi hosts, or, in some places, KVM hosts. Vast majority of customers who are using NSX today and forever have always primarily been doing it, on an ESXi host. That's where we do things. So when we set up an NSX host, we take the physical network interfaces and we match them up to software components on the back end to enable the networky and software things to happen as we build this out. And there's different components all along the way that will stack on top of each other that back themselves into the physical network, so that your virtual networks can communicate with your physical networks and everything is nice and seamless, and we can stretch those networks, and it gets very complex very quickly. But at the same point, the epiphany that I had years and years and years ago when I first started learning NSX back in the vSphere days was, we're not really, reinventing the wheel of networking. Like, we're just taking all of those same network concepts and putting them in software on top of a hypervisor and enabling other security things inside of it. So it's really a lot of the same concepts that network people already know and love, and making them software definable and software manipulatable so that you don't have to deal with all of the physical minutia of, physically cabling a switch and physically stretching networks with, outside forces, and, just trying to keep it all inside of a software mindset, if you will. It's the same kind of idea that all of the hyperscaler cloud providers use. So, the AWSs of the world, all of them are doing their networking all in software. So this is how you can do the same kind of level of network communications from a VMware point of view. So when we start talking about networks, we first talk about the host, and we talk about physical networks, and then we talk about these things called transport zones. And the transport zones kind of define, where things can go. And those are attached then to the virtual distributed switch layer. If it's on a KVM, we're still using the NVDS for KVM hosts, but primarily we're going to talk about ESXi. As we continue building this out, we set up, profiles for how to map the uplinks into the transport zones from the VDS. We attach hosts to those profiles, and then those profiles, uniformly apply their structure across your clusters of hosts, and, assign the PNEC to the uplinks, and it creates this uniform fabric of networking and software that once you turn it on for your clusters that are managed by NSX, they all get the same kind of thing. And then part of this is a little bit of what we talked about last time with those sub transport zone profiles, where if you need to do, an extra jiggering of how your profiles are set up, you can do that with the new sub transport profiles. If you want to learn about that, go back to the last one we just did. So again, a transport zone defines the span of a logical network over the physical infrastructure. Transport nodes can provide or can participate in networks a couple of ways. So we have in the diagram here, a couple of VLAN transport zones, and then a overlay transport zone that is broadly applied over multiple hosts. So VLAN transport zones can typically be applied to physical infrastructure, but you can also still do VLAN-backed networking and VLAN-backed transport zones for physical, for virtual networks as well. So if you're virtual workloads, the VLANs don't have to be exclusively put on the physical architecture or the physical workloads. You can use VLAN backed networks on a vSphere port group and utilize those networks that are managed by external networks, to connect your vSphere workloads to in the same way that you would an overlay network. So it's flexibility and deployment is really the name of the game here. And the overlay side, we gives you more options in how you can stretch networks inside of the vSphere pane. So if you're managing and wanting to carry all this traffic inside of your vSphere view, have security managed by NSX, have networking managed by NSX, have it all managed into one single view. That's where the overlay networks capability comes into play, and it's it's a little bit to set up, but every network is, but it's we try to keep things down to the level of if you have kind of basic entry-level Cisco type networking certification and knowledge, you can deploy networks in NSX. It's very, very simple and straightforward to deploy these things out. Going up a level, then we have the VDS. So the VDS is the vSphere distributed switch. It is the software construct inside of the vSphere hypervisor that allows the network components of the host to communicate with all of the vSphere other vSphere components, and up into and including the physical network port groups and things that get attached, so you can have total communication. ESXi hosts get managed by vCenter, obviously, and they get configured to use. You can have multiple VDSs within a host. It just depends on how many uplinks you have on the host, and then at that point, you can create segments either in NSX directly, and a segment is akin to a distributed port group on a VDS, or you can just create a port group. As long as you're at since we're talking about 4.1 here, we're talking about vCenter 7 or higher, or vSphere 8 or higher, where the port groups are fully consumable by NSX. Older versions of stuff, like back when with the first series of vBrownBags that I did for NSX, those port groups and those segments, you had to create everything in NSX. NSX owned the networking. vSphere port groups were not consumable by NSX back in earlier versions, but that is now fully flipped around so that we can utilize what's already there, or just keep it simple and create a port group or a segment inside of the vSphere client, and then it is fully realized within the NSX view, and you can take advantage of everything that you already know and love. So continuing on review of the networking components here, the transport node profiles, and again, these are the things that the transport zones are defined by, what kind of switch configuration it has. The real kind of magic here is that the transport node profiles make deployments easier by using vSphere clusters to speed deployment and enable faster deployment of NSX infrastructure, and really just to drive consistency and avoid those manual errors of manually plugging these things in and hooking things up. It's just the simplified way of creating a simple profile that gets reused every time that you stand up a new cluster of NSX backed hosts. And so it just consistency is the name of the game, and security and stability, and especially inside of data center networks. And so this is how we do this inside of the NSX environment. Okay, logical switching then. So we've kind of gone and ran the gamut here from end transport zone, VDS, transport node profiles, and now we're into this logical switching, otherwise known as the segments or distributed port groups. So a segment can also be called a logical switch. If you go through the full NSX training for install, configure, manage, you'll see kind of this terminology thrown around where we talk about segments or we'll talk about logical switching. They're kind of one and the same. And we'll talk about port groups kind of in that same vein. But generally speaking, the official terminology when we're talking about a network endpoint that your workloads get connected to in an NSX context, we're going to call it a segment, because there are vSphere clusters that will have distributed port groups that those workloads can get connected to, but they're not managed by NSX. So those are distributed port groups. NSX managed port groups we still refer to as segments because they are doing different things. So it's still providing connectivity to the workloads, but the level of services that then can be applied to those workloads because of what they're connected to differs. So that's kind of why we always try to keep the terminology still separate between the vSphere world and the NSX world. And as you're learning NSX for the first time, these are important things to have in your head, because if you called into support and you were having trouble with this, they would use this terminology as well. So it's good to kind of keep on top of that. And this is very elementary 101 stuff here, but I wanted to do this review before I get into the harder stuff. So bear with me, please. So in a way, segments here are similar to VLANs. Segments segregate networks and they provide network connections, to which you can attach the VMs. The VMs can communicate with each other over tunnels between hypervisors if those VMs are connected to the same segment. This was what allows you to create a segment in one cluster in a data center and stretch it, across to another, and even sometimes, doing wide stretching across sites, depending upon how you want to, how far you want your layer 2 segments to go. And we'll set up, segment profiles to include layer 2 network configuration details as well for logical switches and other logical ports. NSX, the NSX manager supports several types of switching profiles and maintains, one or more system-defined default switching profiles for each profile type. So there's, a lot, and this is again why I talk about the difference between just a standard vSphere distributed port group and an NSX segment, because again, it's 601 half dozen the other, but at the same time, it's just more on the NSX segment side because we're applying firewalls to it. Now we're applying logic around IO control, depending on how much traffic is coming in and out and how we want to manage and mitigate that. There's just a different level of services and things that can be applied to your VMs based on where they're connected. Okay, continuing up the stack. Logical routing. This is where it starts to get a little bit more interesting. When we talk about logical routing in this context, we're talking about what those NSX segments are connected to get their plumbing and to get their networking set up. So we have a couple of different types of gateways that provide connectivity resources and connectivity options, for your workloads. NSX data center gateways do a couple of things. They do north-south or east-west routing. And then we also have the, encased inside of that static and dynamic routing to enable multi-tenancy, high availability. We fully support IPv6 now and multicast. And, it allows, centralized services such as gateway firewalls, network address translation, load balancing, or VPNs, depending upon, what and where you're applying these things and how your design is built. So those aren't all necessarily available, in one design. Usually you're going to have if you have a specific place where you need to stand up an NSX network and have a VPN stood up between NSX networks, you're going to have a specific design for that scenario, but these are options that are available for customers to take advantage of. We'll start with the tier 0 gateway. So again, gateways are distributed across the kernel of each host. So, inside of the ESXi hypervisor host, when you prep that host for NSX, we install bits or VIBs inside of each host to enable these services to run and be fully distributed across the host. Gateway can be deployed as either a tier 1 or a tier 0. Tier 0 gateways provide the north-south connectivity. Both Tier 0 and Tier 1 gateways support stateful services like NAT, and stateful services are centralized on these things called edge nodes. I'm not going to get into the edge nodes too much in this talk. If you want to learn more about edge nodes, you can go back to some of the 2021 series. But in general, the edge nodes is a virtualized cluster of network appliances that have those other services running on them. In the Tier 0, when it has those advanced services enabled, they get deployed on an edge cluster of those things. And edge nodes can be virtual appliances set up in a cluster, or they can be physical appliances set up in a cluster to do dedicated network things. So depending upon your scenario and your situation, that's going to determine what type of edge design you have to go through. The thought process and talk track for edge node cluster design. I have to say that slowly because it's a very specific statement. The thought process for that design is very detailed, and it's something that you have to really think about and go through specific traffic planning and figure out. You don't want them to be too small. You don't want them to be too big. What is your risk tolerance for connectivity issues? It's the same kind of stuff network people have always done, and it's the things that network people do that the rest of the world is hitherto unaware of, and it's the things that we do to make sure that things like vBrownBag work on the internet. So you're welcome.
Oh, thanks.
Yes, I'm speaking for all network engineers everywhere. So
our initial networking issues at the beginning of the show notwithstanding.
Exactly. Yes. Okay. So we started kind of at the top, working our way to the bottom, but now we're actually in the middle. So the Tier 1 gateways, again, provide east-west connectivity. And this is, sort of the first foray of how we started doing multi-tenant network design at the network, software-defined network layer. And then, as we talked about last time, we even have now these components called VRFs, where we can do it. You can do it that way too. So you can deploy multi-tenancy via dedicated T1, or you can deploy multi-tenancy in networks with a VRF. So pick your poison, which way you want to go, how you want to handle things. So a lot of it's all use case dependent, but those are certainly options. Tier 1 gateways must connect to a Tier 0 gateway to access external networks. The Tier 0 gateway, gets directly connected to the upstream physical networks and physical gateways, so it will do the BGP or the OSPF peering or static routing to the external network so that you can get out. But the Tier 1 gateway, has to connect to the Tier 0 to get there. And the one interesting thing to note here is, and this is still true today, and I think it's mostly been true for all versions of NSX since the 2.x days. The plumbing between the Tier 0 and the Tier 1 gateway is auto-configured. So any routes there or networks that get stood up, x.x.x.x, that get stood up inside of this gateway will automatically be learned by the Tier 0, and then it will route out accordingly. And so if a request comes in for a network, the Tier 0 is going to just know, where to send it based on, things that it learns from the Tier 1s. So the Tier 0s and the Tier 1s communicate on their own dedicated, management and, communication network amongst themselves, and they share the information that is required to make connectivity happen. So again, it's another way that we try to make simple, a more simplified way of, turning on these things. I kind of lost my place here where my thoughts were here. Okay. Oh yes. Big point here. The Tier 1 gateway does not require an edge node. So those edge nodes we talked about before, where the Tier 1 lives with, all the advanced other services that it can do. Tier 1 gateway does not require an edge node as long as there are none of those additional services turned on for the tier 1 level. So if you're not using VPN, if you're not using, security services, if you're not using, if you're just doing basic networking splitting inside of the tier 1 to a tier 0, we can do that at the hypervisor level, and it'll get distributed out throughout the hosts. Okay, I think talked through. Okay, let's get into. So that's sort of a quick 20-minute primer on what networking still looks like in an NSXT or NSX 4.x context today. So this is, I think, still showing some of the maturity of the product, whereas we've grown it from the 2.x early days of NSXT to NSX 4.x now. There's been some tweaks to how the product works, been some tweaks to make it more efficient and more scalable and all these kind of good things, and more performant. But in general, the large big block concepts of how we deploy these things has not changed. And so I think for people like me who've had to go through a lot of certification testing, I appreciate that, because we're not going from a gas engine to a hybrid or into an electric vehicle overnight. We're just kind of keeping the transmission still the same. So I like to use a lot of car analogies. So okay, Federation enhancements to the 4.1. So this is just kind of a quick overview of a couple of things that got added to Federation in the 4.x release train. We now support physical servers in federated environments, so we can manage connectivity and security for physical things that are stretched across federated environments. And then we have distributed firewall exclusion lists for things in a federated environment. And this is, the exclusion list is an important thing. I want to just kind of highlight this for a moment. There are and have always been certain things inside of software and otherwise even physical networks that can't or shouldn't have firewalls applied to them. Things that come to mind are VPN appliances, or in a lot of cases, external load balancers, any kind of traffic managing device that throttles traffic between sites, anything that's hypersensitive to stuff stepping on the traffic. So for those kinds of things where you don't want, or where you're going to have a workload in a virtual context on an NSX host with a distributed firewall turned on, we have this thing called the distributed firewall exclusion list, where you basically go into the NSX manager and say, add these VMs to this exclusion list. And what that does is every single VM, when it gets plugged into the network, we stick a firewall in the bits, right on the network connectivity itself. When you put a VM in the exclusion list, it effectively deletes or turns off the distributed firewall. So even if there's no policy set up for that workload, the distributed firewall still exists in the path, and depending upon the sensitivity of the workload, could still cause an issue. And so that's why if you go out to our documentation now, you'll see noted notes out there about things that should be in the DFW exclusion list. And so, this is, and effectively the exclusion list turns the knob fully open so that the firewall is not in play at all for things in that exclusion list. So oftentimes you'll see vCenter put in there, so you don't accidentally lock yourself out of your vCenter. You'll see again, physical virtual load balancers, other kinds of network appliance things, and just it's an important thing to highlight, because as I've gone through my career with NSX, I've seen it happen time and again where somebody accidentally clicks the wrong button and they've locked themselves out of something because they didn't have it in the exclusion list, or it's caused some sort of a slowdown in traffic or some other issue where this thing just needs to be turned on. So it's kind of a it's a small little detail in the product stream, but I think it's really important as you're going through and deploying things. You need to be mindful of what goes in that exclusion list and understand what's happening with that. All right, so we're just going to assume that everybody has multiple on-premise data centers, and of course, they need to scale those for disaster recovery, and they need to have every site has network needs, security needs, and they also have some global network and security needs. So you're going to have things that get deployed in a local context. You're going to have things that get deployed in a global context. This is where federation comes into play to make those things easier to manage. And so kind of like a slight review of what we talked about on the federation side, but I'm going to go a little deeper on this. We do this in the context of a global manager and then local managers at every site. And this is a cluster of local managers and a cluster of global managers. And then it still kind of gives us the, single point of entry for the UI. So, the NSX admin, up here in the corner, they've got access to the global manager UI. They can log directly into the global manager interface, and then if they want to get into a specific local manager, they just click the drop down, and then they can drop down into the local manager in a specific site. And if they need to do a specific local change to that site, they can do it all from one place, and then they can switch back. So it cleans up kind of the NSX admins work stream a little bit, where they can understand their entire environment, and then be able to create the consistent policy and do some compute mobility things. And then if they lose a site because of an tornado hits or flood or whatever, all of those objects can get federated and shared across sites, so we can replicate things with a DR tool like site recovery manager, and then life goes on. I know during the last hurricane event down in Florida, we had a whole bunch of customers who used Federation and SRM and these kinds of tools to evacuate sites, ahead of the hurricane, and so that way they could maintain access to these things and keep things running even in the midst of a hurricane bearing down on an environment. So when we talk about NSX, we talk about there's new terms and concepts in federation that are important to understand. Part of the networking bits that I didn't mention is there's these things called tunnel endpoints, or TEPs. Those are network software defined connection points between the hosts where that the overlay networks run on top of. So each host that's prepared for NSX and that's using overlay networks gets a TEP, and then that TEP network effectively becomes the overlay network that the real networks run on top of. In a federation context, we do the same kind of an idea, but we have this thing called a remote tunnel endpoint, or an RTEP, and that is what enables then the span of networks across federated environments. So when you're deploying these things out, this is kind of where those things come from. All of that comes down from the global manager. So in this kind of context here, we're talking about the local managers. When they get stood up, they connect to the global manager. So that's why the arrows are pointing up at the global manager. Generally speaking, the local manager environments are built first, typically, and then the global manager gets built. The global management active cluster gets stood up. It onboards everything from the local managers, and then it will kind of do a one-time inventory of everything that exists in the local managers and brings them into the global manager view. And then from there on out, any objects and, security tags, security groups, networks, all of that kind of stuff that you want to have a federated overview on or a federated control of gets created at the global manager view. And then it will then be pushed down to the rest of the environment. So, all right, I think I just talked through most of this here by accident. So let me skip through some of the stuff here. Okay. The global manager then, syncs the configuration then with these local managers, only kind of if the configuration is relevant to that location. So for example, if you created a tier 0 gateway and you add it to location 1, location 2 and location 3, the configuration gets synchronized with all 3 local managers. The local managers can only synchronize once with that global manager during that configuration import. So then, after that, the additional changes all come from the global manager directly. And it kind of creates this template, if you will, of, okay, here's what the whole environment looks like. And then we sync that over to the standby cluster of global managers so that it knows here's what the configuration is for the current active global manager. And then, all of the changes, when there's changes that are irrelevant, will get pushed down to the local managers. And if those objects don't exist in the site, then they don't get those changes. Backwards. You can still, though, create objects on a specific local manager. And these objects then will not sync with the active global manager or any other local managers. So, if you're in a federated environment and you need to create a dedicated network that's not going to be stretched, that's only going to exist in one site, you can still do that. And you can, understand and realize, where these things need to be. But otherwise, if you create everything from the global manager view, it's going to sync everything between all the LMs and help things be more readily spread about throughout the rest of your environment. Quick look at the UI here. From a management plane view, when we log into the global manager, we'll see up at the top here, this shows which GM you're currently logged into. You will notice that the menu across the top is generally the same. There might be the little slight differences in that you won't have as many options, and that's also especially true on the main kind of configuration menu of where you see things. So it's not a one-for-one replacement, but it gives you access to the things that you can interact with from a global view versus down to a local view. And then again, if you need to jump into the local view, you just hit that drop down. So we're in that, and then you can view the status of each of the global manager clusters, right from this location manager view. So we can see which one is active. We could see which one is standby. We can also, in the actions pane below there, force a switchover. So if we know there's going to be a maintenance event and we need to do maintenance in the GM Paris location, and we want to switch the active global manager over to London, you can do a switchover and have them kind of switch roles and understand availability and things like that. You can also view the status of local objects. The local managers display, the status of their clusters and their management plane in this same view as well. You can see kind of the onboarding status as you're bringing them in for the first time. And then, of course, maintaining the status of their ability to sync things up to the global manager view and across to other sites. this is actually a little bit of a repeat, so I'm going to skip through that. Let's talk some security use cases here. So you can create distributed and gateway firewall rules from the global manager with, regional or local spans. Just depends on where you want them to be. So most deployments of NSX, we split up the firewall policy kind of based on where things need to be applied within an environment. So we have a whole section of environmental rules or specific global services like DNS and NTP and Active Directory and that and the like. So your groups can be defined globally. They can be defined by regional services within specific areas, or down to the local level based on the specific location that an application lives. In NSX 4.0.1.1 and later, the distributed firewall gets activated and deactivated with one button on the global manager level. And change of distributed firewall enforcement gets reported at the global manager level. And we can't then override it because this is coming down from coming down to the local manager. So we're starting to kind of in the newer releases here. We're moving kind of the globalized control of the distributed firewall, depending upon how your environment is built, into the GM plane, so that we can have a global security context applied to things. And then, of course, groups can be dynamic. And you can have, tag-based policy stood up from a global level and have those tags follow the workloads around. So if you've got network stretched across, if you've got, if the connectivity and the plumbing is all there, then the workload may or may not necessarily need to be in a specific location. And with our ability to tag these things, as long as you have the dynamic policies, deployed in your environment appropriately, everything comes down to design. We can follow those things around and sync tags and make sure that things, stay where they're supposed to be and be protected consistently. All right, networks. So Tier 0 gateways and Tier 1 gateways and segments can span one or more locations in an NSX federated environment. When you plan your network topology, you got to keep a few things in mind. Tier 0 and Tier 1 gateways, again, span more than one location. The span of a Tier 1 gateway must be equal to or a subset of the span of the Tier 0 gateway it is attached to. So you've got some given boundaries here. So if you're, Tier 1 is stretched or not stretched, that's going to dictate, where it can connect to or where it cannot connect to. So again, the details are always in the design here. So you have to really be able to flesh out what your network connectivity requirements are when you're enabling stretched routing in an NSX federated environment. So there's just kind of that, extra amount of planning that you want to make sure when you stand this stuff up on the front end, that you're not kind of limiting the location of where you're putting these things based on how a segment is, or based on how a tier, how a Tier 1 or Tier 0 is configured. Especially if having a layer 2 stretch between sites is a requirement. With NSX Federation, you can deploy a Tier 0 gateway that's, can have a couple of different configurations. So we can stand it up and have it be, fully primary in one site and secondaries in the other sites. Or you can have if you need a kind of a fully active type deployment where it's, available on all sites, that is an option as well. And it kind of gives this stretched active in the, in all locations. So if you have broad networking requirements that are requiring you to ensure, consistent connectivity at all times in all locations. That is something that is a capability with routing in an NSX federated environment. You are still, of course, able to do a non-stretched tier 0 gateway in a federated environment from the global manager. So you create the tier 0 from the global manager that spans, one specific location, and you say, I want to create this tier 0. It's kind of the same way of creating it as you would on a local manager. But the distinct advantage here is you can manage it from the global manager. So, and you're not limiting yourself into how you get into, change that configuration later on. So instead of having to go specifically to the local manager to manage it, you can stay in the global manager view and be able to manage a local tier 0. And those can be done in either active standby or active. All right, let me build this most of the way here. Too far. All right. In active standby tier 0 gateway with primary and secondary locations, there's a couple of things to think about here. Only one edge node is active at a time. So in that situation, a tier 0 can run stateful services. So when you're running a tier 0 with those stateful services, there's going to be one specific edge node typically that takes on those specific stateful services like gateway firewalling or VPN, NAT, the things that we mentioned before. So your routing and how the traffic gets flowing through your environment is going to depend on where your edge nodes are located, and that's why, again, I referred to how the details are always in the design of where these things go. In an active tier 0 gateway with all primary locations, all edge nodes are active at the same time. So therefore, that tier 0 cannot run stateful services. And so, when it's sort of a choice you have to make of, do you need stateful services or do you need, fully active edges in your environment? And you have to kind of weigh how you're going to apply those services in your environment.
And if you did it that way, you would need to have your stateful services locally to each network individually, like your NAT and all that stuff, right? Okay.
Correct. Yeah. So it devil's in the details again. And this is like, I always feel like the networking side of the content of learning about this stuff can be kind of dry and boring, but there's so much nuance in the details that you gotta really, really get into the weeds of it. And I'm not a hardcore networking guy. Like, this stuff doesn't really excite me that much. I like the security. I like the security more, but I know that it's part of the process, and you have to kind of deal with it, and you have to know it.
Requirements, risks, assumptions, and constraints.
Exactly. Let's see here. I think if I look back at the views on the other networking sessions that I did, they were always the lowest number of people who watched those. Okay. Supported network topologies from the GM. So with NSX Federation, you can deploy a tier 1 gateway and provide distributed routing only, or you can configure services on it. So again, it's that same kind of thing. Like, do you need services, or do you need just networking stuff, and which way do you want those things to go? For distributed routing only, the gateway has the same span again as the tier 0 gateway it's linked to. So if you need things to be stretched, make sure they're stretched. If you don't need them to be stretched, make sure you really don't need them to be stretched. It's one of those things where, like, yeah, if you're gonna have to change it later, you're gonna have to stand up some new stuff, vMotion workloads around. Again, do your design work on the front end about what your networks or what your workload networks are required to do. I can't say that enough. I feel like I'm a broken record in this one so far, but it's something that we have to consider at all times. You can configure a tier 1 gateway with edge clusters if you need, if you need to run services in the tier 1 gateway, or if you want to deploy a tier 1 gateway that has a different span than the linked tier 0 gateway. So you can remove locations, but you cannot add locations that are not already included in the span of the tier 0 gateway. So if you go into the VMware administration guide documentation page, we do a very, very good detailed explanation and view about the different modes of services that get applied to tier 0s and tier 1s and how that applies to a federated environment. So in this kind of quick overview that I'm doing, I know I'm not doing it justice. So in order for folks to really learn this in the details, I highly recommend going into the docs.vmware.com page and pulling up the Federation documentation itself, because there's good visuals out there as well as detailed explanations, much more than I have the ability to get into here. All right, so when we have a layer 2 connectivity and we're going to stretch this, the only cross-site communication is through edge nodes. This is to avoid the management of many tunnels or BFD communication between hosts and cross sites. Layer 2 stretched is from ESXi to edge node. That's active for that stretch segment. If it's from edge node to edge node using RTEPs, or edge node to ESXi. The edge node IP that gets used for the remote edge communication is Geneva encapsulated, so it's true overlay network. Unlike a TEP, fragmentation on the RTEP is allowed. So when we're standing up TEP networks between hosts for overlay networks that get stretched inside of a data center, that's where the MTU setting has to be higher than 1700, on your physical network hosts. It's because we can't truncate that frame, and otherwise it breaks the network, because we're adding a bit to every single packet that gets encapsulated in an Ethernet frame and thrown across the network. So we got to have that overhead. RTEPs, however, do not apply in that scenario. They allow us to do some fragmentation of those bits and then get reassembled on the other end. But if you can do it without fragmenting the RTEPs for best performance, like if you have dedicated connectivity between distance sites, and you can stand up a higher MTU setting, if you could go to 1700 or higher, for performance reasons, it is recommended you still do it, because that way you're not having to disassemble and reassemble packets on either end. All right, and this is just a quick kind of path walkthrough of where we look at. And the VNI, that's the virtual network indicator, I think. Oh man, I'm gonna get stung on that one if I get that wrong. The VNI is basically the overlay VLAN address, if you will, because VLANs stop at 4098 or whatever they stop at. The VNIs continue that, and that's the RTEP overview of how we enable the overlay to communicate between sites. Selection of the VNI TEP, for the local side. Again, this is the TEP side, not the RTEP side. Selection of the VNI gets done by the local manager, not the general manager or the global manager. And selection of the VNI RTEP is done by the GM, and then gets communicated to each local manager. So that way they know, what to expect on either end. Let me push this stuff out here. Okay. So if we're going to do some additional communications here out, so say we have one site is active and the other is standby within a site, all edge nodes are active or remote active. Each ESX site goes to its local edge node, whichever is active or remote active, and then forwards to the active. And enables, full connectivity depending upon how things are split out in their configuration. Let me get through this. And this is probably another case where if you want to learn in a much more better detailed view, take a look at the docs page, because there is even a specific federation design guide out there as well for all of this that contains how you would actually go through and implement this stuff. So in addition to the actual documentation, go pull the latest and greatest NSX Federation design guide. I know Dimitri worked extremely hard on that as well. It's really well done as well. Okay, wrapping it up here. So in an NSX federated environment, what happens if we lose a GM and we need to switch over? If the site where the GM, exists today is running everything, we can effectively, everything runs on one site. Say we lose the other site. All of that stuff is because we're using BGP on the network itself. We're going to stand up the same networks on the other site, just at a higher cost. So when everything dies in a disaster scenario, as soon as your underlying network realizes that the routes that were being advertised at a lower cost don't exist anymore, then all of a sudden we're going to start to flip that stuff, and we'll make it happen over, and then use SRM to migrate or to recover your workloads over. And so that effectively gives us, a quick stand up and recovery without having to change the physical fabric and without having to modify any changes on the GM or LM. Really, the only thing you have to do is recover the workloads themselves. So, this is a core use case of a federated environment where, if you want to, if having that recovery time objective, be really short is super important. This is a lot of why customers go to this. In a active disaster recovery, so say we have stretched networks across sites, we have primaries, tier zeros, and advertising sites. Everything's kind of going, where it needs to go, specific based on the BGP again. And then on the secondary sites, we're going to use, again, BGP cost routing to understand, which way things need to go. So we're going to use the same methodology here, but even though we've got workloads stretched in either site, if we lose the site one, the subnets will update according, to their availability. We don't need to recover the compute because the compute's already stretched and it's already active. So is this like in this example, maybe we've got a stretched vSAN cluster where it's just active running workloads and high availability. So really you'll lose a few pings, and then once it comes back up, it'll just be there. And that's, recovering it again without physical fabric changes, without doing anything on the NSX GM or LM, and not even having to recover the workloads themselves. All right. So when we do network and security centrally configured, we're gonna have egress depending upon sites and where things go. The subnets still get advertised from either side. Again, it's pretty simple walkthrough. This is very similar to the same thing, or similar to the first example. Active with a local egress. We're just, again, utilizing the magic of BGP to ensure that routing, when we lose a routing peer, things go where they need to go. Wrap this up with a couple requirements pieces here. For federation, we have to have your GM and LMs running, ideally 3.2 at least. There are, again, some newer features in the 4.x train of releases, so there's benefits to getting to that if you need to do this from a greenfield brand new deployment. Latency requirements between the sites, and then clear that up. And then the WAN MTU, if you can do it on a higher side, that's good to do, but in general, it's not necessarily as strict as we used to be. And even on the bandwidth side, we don't have really any bandwidth requirements, but obviously more is better.
Yeah, that latency requirement is a lot higher than it used to be, isn't it?
Well, this is the difference again for federation. So, it could be because we need to ensure and keep things in sync. So yeah, if you were doing NSX, what they refer to as NSX multi-site, which is where you have a single local manager cluster managing multiple clusters spread across different sites. As long as your connectivity is within an acceptable range, you can actually circle around having to do federation, and you can just do it, with NSX managers. But so, there's design requirements around that too, why you would want that. But you can actually get away with a little bit higher latency in that design as well, because you don't have the overhead communication of the GMs.
Gotcha. Good recovery.
Licensing. So all general, basically, if you need federation, you have to have NSX Enterprise Plus, which is the highest tier of licenses, because this is not for the faint of heart, not for a small deployment. This is something that has to be at the high level. NSX Federation can be completely orchestrated. Again, there's APIs, and you can Terraform and Power CLI this thing all you want to deploy these components. There's automation ways to do these things, and there are examples of those configurations on GitHub for these as well. Always check config-max. We should probably make T-shirts and hand them out at VM Explorer that say always check config-max, because you should always check config-max, Chris. And that is today. I think I'm stopping maybe a little over, but right on time on my clock.
So. Yeah, it's fine. We started late anyway.
Yeah. Nice.
All right. Well, Britton, thank you very much. We are at time for the evening, so we're going to stop this now. If anybody has any questions, they can ask us in the YouTube channel or ping us over on Twitter. And tune in, not next week, but I believe it's the week after, that we are continuing the series, Britton, part 3.
I believe so, yes.
Awesome. All right. We will see y'all then. Britton, thank you once again. Have a wonderful evening, and we will see you all next week.